This tutorial covers mole calculations required for questions involving reacting masses. What mass of aluminium oxide is produced when 8 moles of aluminium is burnt in oxygen? The question gives us the relative atomic mass of aluminium is 27. This means 1 mole of aluminium atoms will have a mass of 27 grams. The relative atomic mass of oxygen is 16. This means 1 mole of oxygen atoms will have a mass of 16 grams, or if we obviously think about an oxygen molecule, O2, 1 mole of oxygen molecules will have a mass of 32 grams. So, first stage, we need to calculate the number of moles of aluminium oxide formed. If we look at the equation, we can see the mole ratio of aluminium to aluminium oxide is 4:2. So the ratio of 1 mole of aluminium to aluminium oxide is 1 mole of aluminium to half a mole of aluminium oxide. If we want to work out the ratio from 8 moles of aluminium to aluminium oxide, we can take this ratio and times it by 8, giving us 8 moles of aluminium form 4 moles of aluminium oxide. If you look at the equation, we have 4 moles of aluminium atoms on the left hand side and 6 moles of oxygen atoms on the left, and the same quantity on the right hand side. The amount of aluminium is not decreasing. The question refers to moles of aluminium oxide, and each mole of aluminium oxide contains 2 moles of aluminium. We now need to work out the mass of 1 mole of aluminium oxide, which is going to be equal to the mass of 1 mole of aluminium atoms times by 2 plus 3 moles of oxygen atoms times by 3, which gives us a total mass of 102 grams. Now we can work out what the mass of 4 moles of aluminium oxide will be. The equation we can use is total mass of moles will be equal to the number of moles multiplied by the mass of 1 mole. So 4 times 102 grams gives us a total mass of 408 grams. How many moles of aluminium oxide are produced when 164 grams of aluminium is burnt in oxygen? This question looks very similar to the last one. However, instead of giving us the number of moles of aluminium, it gives us a mass of aluminium. And it doesn't require us to calculate the mass of aluminium oxide produced, just the number of moles. So the only difference here is you need to convert the mass of aluminium given, 164 grams, into moles before starting. Why not pause the tutorial and see if you can calculate the correct answer on your own? Firstly, we need to calculate the number of moles of aluminium. If we had 1 mole of aluminium, it would have a mass of 27 grams. 2 moles, 2 times 27 grams. 3 moles, 3 times 27 grams. So we could write the general equation below. Total mass of moles is equal to the number of moles multiplied by the mass of 1 mole. However, here we do not know the number of moles, but we do know the total mass and the mass of 1 mole, so we can rearrange the equation. If you're not sure or not very good at rearranging equations, you could do this using magic triangles. So, using this rearranged equation, we can do 164 grams divided by 27, which will give us our number of moles, which is 6 moles. The next thing we need to do is to work out the number of moles of aluminium oxide formed. From the equation, we can see the mole ratio of aluminium to aluminium oxide is 4 moles of aluminium to 2 moles of aluminium oxide. So, if we want to change this so it's got a ratio of 1 mole of aluminium to a certain number of moles of aluminium oxide, we could divide both sides of the ratio by 4. If we now want to make it relate to 6 moles of aluminium, we can times both sides of the ratio by 6, so we get 6 moles of aluminium to 3 moles of aluminium oxide. Thus, if we start off with 164 grams of aluminium, it will produce 3 moles of aluminium oxide. What mass of aluminium oxide is produced when 10.8 grams of aluminium is burnt in oxygen? Why not pause the tutorial and try answering this question yourself? Stage 1 of answering this question is to convert the mass of aluminium oxide into a number of moles. So to do this, we use our equation. Total mass of moles is equal to number of moles multiplied by the mass of 1 mole. What do we know? We know everything apart from the number of moles, so we can rearrange the equation. So we can say number of moles is equal to total mass of moles divided by mass of 1 mole. So 10.8 grams divided by 27 gives us 0.4 moles. Stage 2, we have our moles of aluminium, and we need to work out from using our balanced symbol equation how many moles of aluminium oxide will be formed. We can look at this equation and we see there's a ratio of 4 moles of aluminium to 2 moles of aluminium oxide. Or we could divide this ratio through by 4 to generate a ratio of 1 mole of aluminium forms 0.5 moles of aluminium oxide. To get it to relate to 0.4 moles of aluminium, we can multiply both sides by 0.4, giving us 0.4 moles of aluminium will give us 0.2 moles of aluminium oxide. The next stage is to work out what the mass of 1 mole of aluminium oxide is, which will be equal to 27 grams times 2 plus 16 grams times 3. Now we can work out what the mass of 0.2 moles of aluminium oxide will be. So total mass of moles will be equal to number of moles, which is 0.2, multiplied by the mass of 1 mole, 102 grams, giving us our final answer of 20.4 grams. What mass of aluminium and oxygen is required to produce 61.2 grams of aluminium oxide? We are trying to find a mass of aluminium and oxygen given a mass of aluminium oxide. A balanced symbol equation is given which links them together relating to their quantities in moles. Thus, the first stage will be to convert the mass of aluminium oxide into moles. In this case, we need to work out the mass of 1 mole of aluminium oxide first and can use the relative atomic mass as given. The mass of 1 mole of aluminium oxide will be equal to the mass of 1 mole of aluminium atoms times by 2 plus the mass of 1 mole of oxygen atoms times by 3, which gives us a total mass of 102 grams. What's going to be the mass of aluminium oxide? We can use the equation total mass of moles equals number of moles multiplied by the mass of 1 mole, rearrange it to calculate the number of moles present. So 61.2 grams divided by 102 gives us the fact there are 0.6 moles of aluminium oxide present. Now we can work out how many moles of aluminium are required to generate or form this number of moles of aluminium oxide. From the equation, the mole ratio of aluminium to aluminium oxide is 4 moles of aluminium to 2 moles of aluminium oxide. If we adjust this ratio by dividing both sides of this ratio by 2, we get 2 moles of aluminium to 1 mole of aluminium oxide. We can now multiply this ratio by 0.6 to get the fact that 1.2 moles of aluminium will be formed from 0.6 moles of aluminium oxide. So to form 0.6 moles of aluminium oxide, we will need 1.2 moles of aluminium. The mass of 1.2 moles of aluminium will be 1.2 times by the mass of 1 mole of aluminium, giving us a total mass of 32.4 grams. We now will answer the part about what mass of oxygen is required to form 61.2 grams of aluminium oxide. We know that we are forming 0.6 moles of aluminium oxide, and we can use our balanced symbol equation to work out how many moles of oxygen molecules are required. From the equation, the mole ratio of oxygen molecules to aluminium oxide is 3 to 2. The ratio of oxygen molecules to 1 mole of aluminium oxide is 1.5 to 1. To get this ratio, I divided the previous ratio by 2. If you multiply both sides of this ratio by 0.6, we find that to form 0.6 moles of aluminium oxide, we will require 0.9 moles of oxygen molecules. We now need to calculate the mass of 0.9 moles of oxygen molecules, and we can use the equation total mass of moles is equal to the number of moles multiplied by the mass of 1 mole. 0.9 times by 16 times 2 gives us a total mass of 28.8 grams. In chemical reactions, the mass of reactants should be equal to the mass of products, as mass cannot be created or destroyed in chemical reactions. We know the masses of the reactants and summed they should be equal to the mass of the products. The mass of the reactants is 28.8 grams plus 32.4 grams, which is 61.2 grams, and this is equal to the mass of the product, 61.2 grams, so our calculations are correct. What mass of ammonia is made when 1.4 grams of nitrogen reacts with excess hydrogen? Pause this tutorial, try solving the question, and then restart the tutorial. Firstly, look at the information given, a mass of nitrogen and the relative atomic mass of nitrogen and hydrogen, and also a balanced symbol equation. As we are given relative atomic masses, we could work out the molar masses of nitrogen, hydrogen, or ammonia. We are also given a balanced symbol equation. This means we know what ratio nitrogen and hydrogen combine to form ammonia. In words, the equation states 1 mole of nitrogen atoms combine with 3 moles of hydrogen atoms to form 2 moles of ammonia. Secondly, write down any equations you might use and think what steps you might use to carry out this question. So, the essential equations might be total mass of moles is equal to the number of moles times by the mass of 1 mole. And one possibility for it being rearranged is number of moles is equal to total mass of moles divided by mass of 1 mole. The essential steps could be calculating the number of nitrogen molecules, then the number of moles of ammonia formed, then the mass of 1 mole of ammonia, and finally the mass of ammonia formed from 1.4 grams of nitrogen. So let's go through those 4 steps. Firstly, the mass of nitrogen molecules. We can do this by dividing the mass of nitrogen in the question by the mass of 1 mole of nitrogen molecules. Thus, 1.4 grams divided by 28 grams gives us 0.05 moles of nitrogen. Next, using our balanced symbol equation, we can work out the number of moles of ammonia formed. From the equation, the mole ratio of nitrogen molecules to ammonia is 1 to 2. We can multiply both sides of this ratio by 0.05. Thus, from 0.05 moles of nitrogen molecules, we will form 0.1 moles of ammonia. We can now calculate the mass of 1 mole of ammonia. The mass of 1 mole of nitrogen molecules times 1 plus the mass of 3 moles of hydrogen atoms will give us a total mass of 17 grams per mole. We can now use this in combination with the number of moles we've calculated of ammonia to work out the fact that the mass of ammonia formed from 1.4 grams of nitrogen is 1.7 grams. What mass of ammonia is made when 8 grams of hydrogen reacts with excess nitrogen? Pause this tutorial, try solving this question, and then restart the tutorial. First, write down any equations you might use and think what steps might be used to carry out this question. So, the equations I would write down are total mass of moles equals number of moles times mass of 1 mole, and often it's needed in the rearranged form number of moles is equal to total mass of moles divided by mass of 1 mole. The 4 stages would be calculating the number of moles of hydrogen molecules. Then we'd want to use the ratio which is given in the balanced symbol equation between hydrogen and ammonia to work out the number of moles of ammonia formed. Then calculate the mass of 1 mole of ammonia, and then calculating the mass of ammonia formed from 8 grams of hydrogen. So, firstly, let's calculate the number of moles of hydrogen present in 8 grams. We take the mass, 8 grams, and divide it by the mass of 1 mole of hydrogen molecules. 8 grams divided by 2 grams gives us 4 moles. Now looking at the equation, the ratio of hydrogen molecules to ammonia is 3 moles of hydrogen molecules to 2 moles of ammonia. If we adjust it down to 1 mole of hydrogen molecules, we can say the ratio is 1 mole of hydrogen molecules to 2/3 a mole of ammonia. We do this by dividing both sides of a previous ratio by 3. Now, to adjust the ratio for 4 moles, multiply both sides of the ratio by 4. So 4 moles of hydrogen molecules will give us 8/3 moles of ammonia. So from 4 moles of hydrogen molecules, we will form 8/3 moles of ammonia, which is equal to 2.67 moles to 3 significant figures. If you're happy with the maths, you could just carry out the following calculation. Divide the number of moles of hydrogen calculated here by the number of moles of hydrogen in the simple equation, which is 3, and then multiply it by the number of moles of ammonia in this simple equation. Next, to calculate the mass of 1 mole of ammonia, it consists of 1 mole of nitrogen atoms plus 3 moles of hydrogen atoms, giving us a total mass of 17 grams. The total mass of ammonia formed will be equal to the number of moles, which is 2.67, multiplied by the mass of 1 mole, which is 17 grams, giving us a total answer of 45.39 grams. Have you cracked it yet? Generally, you have to perform a calculation, use a ratio, and then perform a calculation. Crack. Finally, this has absolutely nothing to do with chemistry, but I thought we'd finish with a dingbat. This has absolutely nothing to do with chemistry. Can you read this dingbat out? The answer will be in 3, 2, 1. Too wise you are, too wise you be. I see you are, too wise for me.